right? All right, so we go back and we start out with solving inequalities. But before we solved inequalities, we looked at solving problems with either variables on both sides or getting rid of parentheses, right? So in these problems right here, we still have to, those are the first things that we're going to try to do with every single problem, right? We're going to try to eliminate parentheses, and then we're going to combine like terms, which are my variables, okay? If the variables are on opposite sides of my equal sign, I'm going to always bring which one towards which one? Smaller towards the bigger, so we eliminate negatives. And then we, after that, try to isolate our variable. If there's parentheses, we distribute first and then do the same thing. If the variables are on the same side of the equal sign, we just do the problem as it is. If they tell me to add, we add. If they tell me to subtract, we subtract. Okay, so as I'm writing this one up here from the quiz, look on page 360, and if you want to go through 11 through 19, or actually 11 through 25, any of those. So those of you that have quiz problems, this is number 13. But it is basically the same kind of problem, so we'll do it right away. Couple things also, you are getting way better, everyone, at showing work. Some of you have always been good at showing work, some of you haven't, but you are getting better at it. So continue to show work. So again, this is one of our problems, right? First thing that we're going to try to do is eliminate parentheses. So we're going to distribute. Remember, when I distribute, you have to make sure you multiply through all of the parentheses. So we get 10n plus 6 is less than. 5n doesn't do anything, it just comes down. Then I'm going to distribute through my parentheses again. 2n plus 6. So here is where we're talking about. If I have n's that are on the same side of the inequality or equal sign, I'm just going to do the problem. So that means 5n plus 2n is how much? 7n. Everything else just gets brought down. And again, this is what I'm talking about showing work. Don't be afraid of using a bunch of space. If you got to use 2 pieces of paper, I'm good with that. So which way am I going to move my ends? To the left, right? If I move my ends to the left, that tells me I'm moving my numbers to the right. And again, if that bothers you, don't do it in one step. So I subtract 6 on both sides. My ends, 10n minus 7n, 3n. What happens to my numbers? They cancel out. Less than. What's 7n minus 7n? They cancel out. What's 6 minus 6? They cancel out. Well, what happens when I don't have anything over here?
0.
I have 0. 0 is a number. 0 is okay to have in a problem. A lot of people don't like 0. I don't know why. He's a pretty cool cat. Okay? So, how do I solve for n? Whatever I do to one side, I got to do to the other side. 3's cancel out, I'm left with n. Is less than. What's 0 divided by anything?
0.
0. There's my answer. How do I graph it? Boom. Show 0. Oh, wait, it's 0. Put an open circle there. Where are the ends that are less than that? The negative numbers. Color in my arrow. Why do I color in the arrow? Goes on forever, right? Why do I have a shade?
Because it shows that it can be any number.
It shows all my answers. Exactly right. So, some of you thought this was no solution. Wrong. Didn't you there, big boy?
I got it right.
All right? Okay with that one? That was a really good problem. It had basically everything in it.
Wait, you gotta go.
Okay? Go back. Zip it. 11 through 25 on the book.
23.
23. 1/2 t plus 8.
Multiply by 2.
then what?
Equals 3/4 t.
Right? Okay, so here's a problem where you can do one of two things. I can distribute first and then try to get rid of my fractions, or I can get rid of my fractions before I distribute. What do you want to try?
Get rid of the fraction. No, distribute first.
You want to distribute first. We'll do it. We can do it both ways if you want. If I distribute here, I get 1/2 t. What's 1/2 times 8?
4.
Plus 4 equals 3/4 t. Okay? Now, do you want to work with fractions, or do you want to try to get rid of the fractions? Get rid of them. So I'm going to multiply, and I'm going to multiply by the common denominator in sense, or always the bigger one. So I'm going to multiply this by 4. Now, like Alex was going to do, you could have done that right away here to this first problem. If I'm going to do it to the first problem, remember, when I distribute my 4 through the problem, I cannot go inside those parentheses. It's like that parentheses is a barrier. It won't let it in. Okay? Down here, what's 4 times 1/2? 2t plus. Do not forget to multiply by the numbers. That's where some of you are still struggling. Got to multiply by the whole thing so we get 16. What's 4 times 3/4? 3t. So another really good problem right here. Now I'm going to bring my t's together. Which way am I going to move them?
Right.
To the right, right? 2 is smaller than 3, so I subtract 2t from both sides, and I actually get my answer, right? The 2t's, same term, but different signs, so they cancel each other out, and we get t is equal to 16. So that was a really good problem, too. Again, on the equals problems, should I really miss any of them? No, because I can take my answer and put it back into the equation, right? And check it. All right, something like 12 or 17, I'm basically going to do that same concept right there. I'm going to multiply everything by 10 in that situation, though, to get rid of the decimals. Okay. Any others? So as going along with this section right here in the book, more of this section than this section, because this would have been the last section. This section right here, if I solve the problem and we get something like this, 4 equals 8, is that ever going to be true? No. So what is my answer?
0.
No solution. If I get 4 equals 4,
Everything's possible. Infinite.
infinite number of answers, or I don't know if I've told you guys this, or you can write the big R. The big R means all real numbers. That means I can put anything in there. Same as infinity. So you'll see either one of those. Okay? So just keep those in mind. I don't know if we had one of those on the quiz, but there might be one on the test. Okay? All right, so going back to looking at 11 through 25. Any more of those? Negative r plus 4.2. Can you help me out here?
Equals 8.8 r plus 14.
Okay. So again, I don't like using decimals, especially if I can't use my calculator. So if I take your calculator away, now again, you could go ahead and use them, but I don't like them. So I'm going to multiply the whole thing by what? 10. Why 10? That's where the decimal is. Perfect. So I'm going to put a 10 out there and I'm going to distribute. So again, remember, hit every single spot in the problem. 10 times negative r. 10 times 4.2. 10 times 8.8 r. 10 times 14. So, unfortunately, the problem with these is the numbers get bigger, but I'd rather use big whole numbers than decimals. Okay, so which way am I going to move my r's? Right, because a negative is always smaller than a positive, right? So, I'm going to add 10r to this, both sides. And if I'm moving my r's to the right, I'm moving my numbers to the left. So I'm going to subtract 140. My 10r's cancel each other out. Same terms, but different signs, so they still cancel each other out. What's 42 minus 140?
Negative
88 plus 10.
98.
What happens to my 140s? Cancel out again. What's R? How about negative, right? So I got to remember all of my sign rules. And again, this right here, I didn't show it, but divide by 98. Oops. Divide by 98. One negative, one positive, opposite sides means my answer is always negative. Okay. Any others in those two sections? Basically don't have to do anything then on 7.3. 7.4 and 7.5, I don't want to downplay them, but hopefully they're very simple because they're just one-step equations. When we get to 7.5, the biggest thing that we have to remember in 7.5 is if what? Change the inequality sign, right? We got to flip it, okay? Multiply or divide by a negative. Not that a negative's in the problem, that you multiply or divide by a negative. That's a huge thing, too. So just because there's a negative number in the problem, doesn't mean that I have to switch my inequality sign. What about something like 37? I want to show that one. Negative 5/6 A.
Is less than or equal to 2.
Thank you. So, if I'm going to get my A by itself, what's happening right here is multiplication. Can I divide my fractions?
Did
No.
you say you wanted your negative on the bottom?
No, I just want my negative with the number. I don't care what number.
He means you just.
When the negative, what you're thinking of is if it's like this. When they're a variable and a number, then I want the number to get the negative. I don't care about which part of the fraction. Okay, good question. So, can I divide by fractions? No, I have to what?
Multiply.
By the,
Reciprocal.
what's the reciprocal mean?
Just the
Opposite.
upside down.
-6/5, right? Or you can put the negative wherever you want. If I multiply that by that on one side, I have to multiply by -6/5 on the other side. Again, I multiplied by a negative, so that tells me what? I got to switch the inequality sign. Why do I use a reciprocal? Because if I look diagonally, they should cancel out. My numbers cancel out, and two negatives make a positive A. That's our goal, right? Over here, every time that I do this and I have fractions and I'm multiplying, the first thing I should look to is simplifying diagonally. If I can't, then I'm going to multiply straight across the top and straight across the bottom. So 2 times -6.
Negative 12.
-12/5. And again, if I was going to graph this, I don't even care what -12/5 really is. I just know that it's negative. So there's -12/5, open or closed circle.
Close.
Closed or a dot, right? And which way do I shade? Right. And color in the arrow. Ladies and gentlemen, again, I think some of you looked at just the symbol, which way I was pointing to shade. You can only do that if the variable is on the left-hand side. Okay. Questions here? Then the last section is kind of what Mr. Colbeck started with over there. So 38 through 43, any of those that you would like to see? There's actually a couple pretty good problems in this section if you want to look at them. Yes, dear.
43.
43. 1/4 plus 2b. I'm going to change it to 1/4 plus 2k because I just don't like b's. Then what?
Which one are we doing?
13 plus 5b. Okay. So again, I don't like fractions. So what am I going to do? Multiply the whole thing by 4. Right? There's only one this time, so yeah. So here's another huge thing right here. When people would do this by themselves, they're going to start going and they're going to say, well, 4 and 4s cancel each other out. I don't have anything left there. That's wrong, right? I got a 1. That's a really important one too. Okay, 4 times 2k, 4 times 13, 4 times 5k.
20.
Which way am I moving my case?
To the right.
Subtract 8k, subtract 8k, that means we're moving our 52 to the other side. 1 minus 52.
Negative 51.
8k's cancel each other out. 52 minus 52, out. 20 minus 8k.
Positive 12K.
Really good problem right here. When I divide by 12, right? I gotta do that on both sides. I take a negative divided by a positive. Do I have to switch my inequality sign? No, it only happens when that bottom number is negative. So my 12s cancel out, k is greater than. Can I take something out of both 51 and 12?
3.
3, what's 51 divided by 3? Negative 17 fourths. So again, make sure you simplify that fraction as far as you possibly can. Okay? And that would be my answer. So again, this is one right here. If we had to graph this problem right here, I'm shading what direction? To the right. I want the k's that are bigger than that right there. So you can't just go by the symbol. All right? Any more in that section? Still got a couple minutes.
I have a question on the.
Yes.
Can we do 40 as well?
46 is greater than or equal to r plus, or r over 7, and then what was it?
Plus 1.
Plus 1. Perfect. So, finally, I'm going to come over here where the variable part is and cover up that variable part. How do I get rid of a positive 1?
Subtract 1.
I'm going to subtract 1. So, I subtract 1 from both sides. 6 minus 1 is 5. My 1's cancel out. R over 7. This is division. So I show or get rid of division by multiplying. I'm going to multiply by 7 on both sides. So 35 is greater than or equal to R. Yes. Which one?
Yes. 14 and 15.
14 or 15? Oh.
Mainly 14.
14 is 18 minus n divided by 2 is less than or equal to 6. So, a couple different ways you could do this problem right here. But basically, all this is a fraction, right? So, a fraction means that I'm doing division, so I'm going to multiply both sides by that denominator. So, I'm going to multiply by 2 in both cases. See how my 2's still cancel out? I get 18 minus n is less than or equal to 12. I cover up my n part, or I can add my n part. It doesn't matter. Okay? So if I cover up my n part, I'm going to subtract 18 from both sides. So I get negative n is less than or equal to 12 minus 18 is negative 6. And then I would have to divide by negative 1. So then I get n is, because I divided by negative 1, I have to flip-flop my sign too. So that's where up here, remember how I said you should always add?
I did that.
Okay, so then you should have had 18 is less than or equal to 12 plus n.
Yeah, but I did 2 different things and then I went with the one. Yeah. See, look at my work. Look